Hello learners, welcome to this video lecture on the topic Communication Electronics. Myself Dr. S.S. Gomati, Associate Professor from PG and Research Department of Physics, Sri Sharda College for Women, Autonomous, Salem 16. In this video, we are going to discuss about satellite communication. Outline of my presentation. Let me start with introduction, evolution of satellite communication, satellite orbits, Kepler's laws of planetary motion, equipments on satellite, the various frequency bands allocated for satellite communication, advantages, applications of satellite communication, and finally, summary. So, coming to the introduction about satellite communication, a communication satellite is an orbiting artificial Earth satellite that receives a communication signal from a transmitting ground station, amplifies and possibly processes, then transmits back to Earth for reception of by one or more receiving ground stations. Communications information neither originates nor terminates at the satellite itself. The satellite acts as an active transmission relay, similar in function to relay towers used in terrestrial microwave communications. And here is the ground station. An uplink, that is, signals are transferred from the ground station to the satellite, and this here the signal will be amplified, then processing will be done, and the information will be retransmitted towards the earth station through the downlink. So this will be acting like a transmission relay. So coming to the evolution of communication satellite. Satellite communication has evolved significantly since its inception, transforming global connectivity, broadcasting, navigation, and defense. So in 1965, the first communication satellite was launched into the orbit, and the growth took place in around 1975. The number of satellites reaches significant levels. And next comes the development in 1983, where new geostationary satellites have been introduced. And this development has been expanded in 1995, and global satellite networks start emerging rapidly. In 2005, innovation starts. Advancements in technology enhance bandwidth capabilities. 2015, increasing utilization of satellites for mobile services. And in 2023, that is the future, which is deployment of next generation satellites for global coverage. And so far, we have achieved major milestones in the evolution of satellite communication. And during early 1950s, both passive and active satellites were considered for the purpose of communications over a large distance. Passive satellites, though successfully used in the early years of satellite communication, with advancement in technology, active satellites have completely replaced the passive satellites. So, a discussion about passive satellites. A satellite that only reflects signals from one Earth station to another or from several Earth stations to several others. It reflects the incident electromagnetic radiation without any modification or amplification. It can't generate power, they simply reflect the incident power. The first artificial passive satellite, Echo 1 of NASA, was launched in August 1960. And there are some disadvantages of while using passive satellites, and they are: Earth stations required high power to transmit signals. Large Earth stations with tracking facilities were expensive. A global system would have required a large number of passive satellites assessed randomly by different users. Control of satellites not possible from ground, and the large attenuation of the signal while traveling the large distance between the transmitter and the receiver via the satellite was one of the major, most serious problems. And coming to the active satellites, they simply amplify or modify the and retransmit the signal from the earth. Satellites which can transmit power are called active satellites, And there are several advantages over the passive satellites, and they require lower power earth station, less costly, not open to random use, directly controlled by operators from ground. And this was the first active satellite which has been launched into space. And disadvantages: a requirement of larger and powerful rockets to launch heavier satellites in orbit, requirement of onboard power supply, and interruption of service due to failure of electronic components. So, let us discuss about the orbits. Orbit is nothing but the path of a satellite that follows around a planet that is defined as an orbit. Satellite orbits are classified into two broad categories. They are non geostationary orbit and geostationary orbit. Satellite orbits, you have got three classification here: equatorial orbit, inclined elliptical orbit, and polar orbit. So, coming to the equatorial orbit, the orbital plane lies in the plane of the equatorial plane of the Earth, and the inclination is zero or very small. Where here in the inclined elliptical orbit, all orbits other than the polar and equatorial orbit makes an angle. The satellite moves from pole to pole and inclination is equal to 90 degree in the polar orbit. And these three diagram represents the equatorial orbit, inclined elliptical orbit, and polar orbit. Satellite orbit in terms of the orbital height. So I've got three classification here. That is, according to the distance from the Earth, they are classified as geosynchronous Earth orbit, medium Earth orbit, and low Earth orbit. And these three diagram represents the three satellite orbits in terms of the orbital height. One is geosynchronous Earth orbit, which is 35,786 km above the Earth, and medium Earth orbit is 8,000 to 20,000 km above the Earth, and low Earth orbit, which is 500 to 2,000 km above the Earth. Orbital elements, you have got three components here: inclination, eccentricity, altitude control. Inclination, the angle between the satellite's orbital plane and the Earth's equator. Eccentricity is nothing but the shape of the orbit, which may be circular or elliptical. Altitude control, that is controlling the satellite's altitude, which is nothing but the orientation, and maintaining the current position in space using sensors which can be used to measure orientation and position, and actuators like thrusters and magnetic tugs. Satellite position, you have got determining position and position accuracy. And in determining position, satellites are tracked using ground based tracking systems and radar systems. And precise positioning is crucial for navigation and other applications. Satellite launching, it is nothing but rocket technology. You can use launch sites or orbital insertion. In rocket technology, powerful rockets are needed to launch satellites into orbit. Launch sites are strategically located to take advantage of the Earth's rotation and the other factors. And third one is orbital insertion, which is the process of placing the satellite into its intended orbit. And Johannes Kepler derived three laws based upon his observations, and they are Kepler's first law, which is law of ellipses. The orbits of the planets are ellipses with the sun at one focus. And coming to the second law, which is law of equal areas, the line joining the planet to the center of the sun sweeps out equal areas in equal intervals of times. And here is the position of the sun, and the planets will be revolving around the sun in elliptical orbits, and the area covered by them is taken as A1, A2, A3 at different time period. So A1 is equal to A2 is equal to A3, and that is Kepler's second law, which says that that is the line joining the planet to the center of the sun sweeps out equal areas in equal intervals of time. And coming to the Kepler's third law, law of harmonics, the square of the orbital period of a planet is proportional to the cube of the orbit's semi-major axis. Here, A is the semi-major axis and B is semi-minor axis. and t squared is the period of a planet around the sun, and a is nothing but the semi major axis. So t squared is proportional to a cube, where t is the time taken to complete the orbit and a is the length of the semi major axis. So coming to the major topic, which is equipments on satellite, and this block diagram represents the various electronic components present inside the satellite, that is antenna subsystem, transponders, power generation and conditioning subsystems, command and telemetry subsystem, thrust subsystem, stabilization subsystem. So let us discuss one by one. So coming to the antenna subsystem, it consists of equipments for receiving and transmitting the signals. To keep the antennas pointing always towards Earth, the antenna subsystem remains stationary. Here it is the antenna subsystem. It remains stationary while the body of the satellite spins. And next is the transponders. Here, the equipment which receives a signal, amplifies it, changes its frequency, and retransmits it is called transponder. Most satellites have more than one transponder. The bandwidth handled by a transponder differs from one satellite design to another, but most of the satellites will be having a transponders of the bandwidth 36 megahertz. And next is the power generation unit, that is power generation and conditioning subsystems. It generates power for the operation of all the units on the satellite and convert the power generated into the form useful for operating all the electronic equipments. So here the solar cells plays a major role. That is, solar cells are used to convert sunlight into electricity. These cells are made of doped silicon crystals. They are connected in series and parallel to meet the voltage and current requirements of the satellite. So the power from the cells is conditioned before use in order to provide the different voltages and currents needed by the various components on the satellite. Conditioning also compensates for falling off the array output with time. Here is the solar panel, which consists of solar cells for utilizing the sunlight energy for operating the various electronic components present in the satellite. And next is the command and telemetry subsystem, which transmits data about the satellite to Earth and receives and commands from Earth. Thrust subsystem, it is used for keeping the satellite antenna pointing in exactly the right direction. And finally the stabilization subsystem, which will keep all the electronic components in a stable condition. So linkages, there are three linkages. One is uplink, downlink and crosslink. In satellite communication, uplink refers to transmission of radio signals from Earth to a satellite, and downlink refers to a transmissions from a satellite towards the Earth, and crosslink refers to transmissions between two or more satellites, that is inter-satellite link. So this diagram is for uplink and this is for downlink. Here the earth station will be a transmitter and satellite will be the receiver. And here in the downlink the satellite will be the transmitter and the receiver will be the earth station. Whereas in the crosslink, for example, in this diagram we have taken three satellites A, B and C, and the distance between the three are also given. And this is the link between three satellites, which is called crosslink. So we can have more than you can have transmissions between two or more satellites, and the distance between the two are also given as 45,458 miles. And here the angle between the two satellites will be, orientation will be 120 degree each, so you'll be getting 360 degree in total. So this table represents the frequency bands allocated for satellite communication, and these are the bands which are being allocated, and this is the downlink frequency and this is the uplink frequency. Here for UH, that is ultra high frequency for military purposes, the range is between 250 to 270 megahertz, whereas for the uplink it is 290 to 312 megahertz. For C band commercial, It is from 3,700 to 4,200 for a downlink and 5,925 to 6,425 for uplink. For a commercial X-band, the frequency limit is from 7,250 to 7,750 megahertz for downlink, and for uplink it is 7,900 to 8,400 megahertz. Ku band commercial 11,700 to 12,200 megahertz for downlink, and for uplink it is 14,000 to 14,500 for down uplink. K band commercial 17,700 to 21,200 megahertz for downlink, whereas 20 it is 27,500 to 30,000 megahertz for uplink. And Ka band military, it is 20,200 to 21,200 for downlink and 43,500 to 45,500 megahertz for uplink. Coming to the advantages of satellite communications, there are several advantages. Global coverage. One of the most significant advantages of satellite communications is its ability to provide global coverage. Satellites can reach remote locations where traditional communication infrastructure is not available, making it an ideal solution for areas with little or no infrastructure. High speed. Satellite telecommunications can provide high speed data transmission, making it a useful tool for businesses that require fast internet connectivity. Flexibility. Satellites can be quickly repositioned to cover different areas or to provide additional capacity, making it a highly flexible solution. Reliable. Satellite telecommunications is less susceptible to disruptions caused by natural disasters or other events that can damage traditional communication infrastructure. And there are certain limitations of satellite communication. One is cost. Satellite telecommunications is a costly technology compared to traditional communication infrastructure. The cost of launching and maintaining satellites is high, which can make it challenging for some organizations to adopt this type of technology. Latency. Satellite communications can suffer from latency issues, which can cause delays in communication. This is due to the distance that signals have to travel between the Earth and the satellite, which can result in a delay of up to zero point 0.5 seconds. And third one is weather dependency. Satellite telecommunications can be affected by weather conditions such as rain, snow, or storms, which can weaken or disrupt the signal. This can cause interruptions in communication and affect the quality of the signal. Security. Satellite telecommunications can be vulnerable to hacking or interception, which can compromise the security of the data transmitted. And these are the applications of satellite communication, that is remote sensing satellites, meteorological satellites, communication satellites, navigation satellites, military and scientific satellites. Let us discuss one by one in detail. So, remote sensing satellites are equipped with sensors that gather data about Earth's surface and atmosphere, transmitting this information for analysis and various applications, including environmental monitoring and resource management. And this diagram represents the remote sensing satellites. Next one is meteorological satellites. Meteorological satellites, also known as weather satellites, are Earth observation satellites primarily used to monitor weather and climate by collecting data from space using remote sensing techniques. So there are some examples of meteorological satellites: INSAT 3D and INSAT 3DR, that is geostationary operational environmental satellites, and also television and infrared observation satellites, etc. Coming to the third type of satellite communication, which is communication satellites, which is nothing but an artificial satellite that relays and amplifies radio telecommunication signals, creating a channel between a source transmitter and a receiver at different locations on Earth, enabling communication across vast distances. Examples: INSAT, GSAT, Telstar, and SYNCOM. And coming to the fourth type of satellite communication, which is navigation satellites. Navigation satellites, part of Global Navigation Satellite System, that is GNSS, provide autonomous geopositioning by transmitting signals, allowing users to determine their location, navigation, and timing. Four global systems are currently operational in four different countries, and they are listed here. And this diagram represents the navigational satellites. And finally, military satellites, and they are used for intelligence gathering, navigation, and military communications, while scientific satellites conduct research on Earth, the Sun, and other celestial bodies. Examples: GSAT 7, that is Rukmini, GSAT 7A Angry Bird, EMISAT, Cartosat 2 series. A scientific satellite or probe carries instruments to obtain data on magnetic fields, space radiation, Earth and its atmosphere, the Sun or other stars, planets, and their moons, and other astronomical objects and phenomena. Aryabhatta, which is India's first satellite, designed and fabricated in India, was launched in 1975. Various scientific satellites, they were used to study space radiation, Earth's magnetic field, and also other phenomena. And the scientific satellites, a scientific satellite or probe carries. And finally, summary: satellite communication is a system that uses artificial satellites in orbit around the Earth to transmit information like voice, video, and data between ground stations and user terminals, enabling global coverage and long distance communication. And you have got two types of satellites here: observatory satellites and communication satellites. And the communication satellites is further classified into passive and active satellites. And communication satellites, they are used for long distance communication process, and they are in fact synchronous satellites. Both passive and active satellites are used for communication, and satellite communication has evolved significantly since its inception, transforming global connectivity, broadcasting, navigation, and defense. And there are the major satellite orbits, that is geostationary orbit, medium earth orbit, and low earth orbit. Geostationary orbit, which is nothing but fixed position above the earth, that is 35,786 km, used for broadcasting and weather satellites. And medium earth orbit, which has got an altitude of 2000 to 20,000 km, mainly used for GPS and navigation systems. So low earth orbit, as we have already discussed, that the altitude is from 500 to 2000 km, used for internet services, example Starlink. And we also discussed about the three Kepler's law of planetary motion, designed by that is discovered by Johannes Kepler, and they are law of ellipses, law of equal areas, and law of harmonics. And also the block diagram for the equipments used in satellite, which is nothing but you got a power system, solar panels, then command and telemetry system, thrusters and transponders, etc., which are all the various electronic components present in the satellite. And also the linkages, which has got three divisions: one is uplink, downlink, and crosslink. All the ground equipment along with the transmission path and receiving antenna at the satellite are included in the uplink system. And coming to the downlink, it is a communication from the satellite towards the earth station, and it is described in terms of satellite transmitter output, downlink antenna gain and beam width, and the ground area that the transmitted signal will serve. And crosslink, A minimum of three satellites placed 120-degree apart in the clock orbit would cover all of the Earth's surface but the polar regions. So A, B, and C are satellites we have discussed, and they are interlinked between the three satellites will lead to cross link. Intelsat was the first to set up such a communication link with the vehicles spaced over the Indian Ocean, Atlantic Ocean, and the Pacific Ocean at the equator. And we also discussed about the frequency bands, that is the assignable satellite frequencies, which can be used for a military purpose only or multi-mission terrestrial and telecommunications, and multi-band for telecommunications only, which may include maritime services at 1.5 gigahertz to 1.65 gigahertz for data and communications with ships at sea. And advantages, there are several advantages, and also the applications of finally the satellite communication system. And the applications we can discuss about the maritime satellite, telecommunication satellite, broadcast satellites, and also that is mobile satellites, satellite communication. And these are the multiple choice questions for practice. So you can very well go through this and get familiarized with the subject. And these are the references. So communication satellites bring the world to you anywhere and anytime. Thank you.